Welcome to the lecture series in computer science on principles of deep learning. Dear students, in this session I am going to introduce you to the concept of deep learning and the neural networks. In today's session, we are going to know about what is deep learning, the limits of traditional computing, the artificial intelligence, machine learning and deep learning, what is the comparison between them, the importance of deep learning, various applications of deep learning, the components, frameworks, challenges and about the neural networks. While moving on to the definition of deep learning, we all know that deep learning is a subset of machine learning that uses the multi-layered neural networks called deep neural networks to simulate the complex decision making power of human brain. Now, moving deep into the definition of deep learning, just think about in olden days how we will do the programming. There might be a list of programming languages like C, C++, etc. and using these languages we will be developing applications that automate our real world day to day applications. Then comes a concept where called the machine learning is into picture. Using this machine learning, instead of doing a traditional programming, the developers have built some learning into the system where the machine understands the data set and comes with different patterns. Then comes the next concept of deep learning. Here this is a subset of machine learning and here the concept is to mimic the human brain. As humans, how our brain works by correlating with the images, this deep learning concepts takes the or grasps the concept from the human brain with the neurons and it helps in the complex decision making power of human brain. Moving on to the more complex definition, the deep learning is one of the methods in artificial intelligence where it teaches the computers to process the data that is inspired by the human brain. Here, while doing or while building these models, we have to recognize the complex patterns, that is any of the patterns. The data might be in form of a picture, a JPEG image or a text, a sound file or some other data, and using all these data we have to provide the accurate insights and predictions. While moving on to an example how this neural networks been represented, we have to think deeper of this as some input will be given and output will be produced. We all know in any traditional programming language our goal is to supply some input and get output. Here in case of deep learning, instead of the programming logic, here the hidden layers helps to consume the input data in form of pictures, videos or sounds. They use different layers and they process the information using a model called the machine learning or a deep learning model and then produces some output. Now, we will look into the history of deep learning. Here we have to think about how the deep learning has been evolved. Just see, in 1993 neural networks will be introduced by McCulloch and the Pitt, and from there the years they introduced backpropagation algorithm in 1974, and then comes the multi-layer perceptron concept in 1986 and then the RNN networks in 1986 and thereby LSTM in 1997, and now we are into GAN networks. So, these are the historical patterns of deep learning, how it evolved over the years. Right from 1940s to 2014, the deep learning models have come from the understanding of visual images to generating of visual images. Now, we will just look into what are the limitations of traditional programming. We all know that the traditional programming just takes the programming languages help and build applications which will be useful for humans where to make up the process speed. So, while moving on to the models like deep learning models, in what way they are helpful, we can see the scalability, flexibility and data pre-processing of traditional programming as a disadvantage. While moving on to the scalability, traditional programming computing will just scale up to limited amount of data, and in terms of flexibility they are not into the different programming platforms, they are not open to it. And moving on to data pre-processing, we in deep learning models have to consider large amount of data, which is very impossible in case of a traditional programming languages. So, now we just have to visualize the actual difference between artificial intelligence, machine learning and the deep learning. The overall what all the concepts we automate the computer with the help of human intelligence, and human intelligence is embedded into the subject is called the artificial intelligence. This artificial intelligence encompasses all the three: machine learning, data science and the deep learning. Now, moving on to the exact definition. Artificial intelligence, here we develop the machines to mimic the human intelligence and behavior. So, by going through this definition, we understand that we are building machines, and these machines, they will mimic the human intelligence. That means, we are providing intelligence to the system to take the decisions. Moving on to the next one, the machine learning. Here we develop the algorithms, and these algorithms, they learn from the structured data and they predict the outputs. Here just see the difference between AI and ML. Under ML, we are going to build the models, and these models are nothing but the algorithms, and they take the data, and the data will be in the structured format, and they are helpful to predict the output or find some unknown patterns in the data. And moving on to the latest one, the deep learning. From ML to deep learning, the only difference is here also we develop the algorithms, but these algorithms are mainly useful for processing the complex data, and these complex data, how they have been modeled using our human brain, the same way how our human brain detects the patterns in the from unstructured data sets. Here deep learning takes power from the unstructured data set. So, we just conclude the exact difference between AI, ML and DL as follows. Now, see the importance, there comes in between the three differences only comes the importance of deep learning, like they are very much helpful in just analyzing the large complex data, and it is a well performed one with respect to the execution or processing feed, and here the features are extracted automatically, and it is a continuous learning process. It goes again to see that the model fits to 99% of the accuracy. The versatility and the human AI interaction is this deep learning concept is more famous in these days. Now, moving on to the exact comparison between the machine learning and the deep learning. Here we will first understand the exact definition, and then we will compare the modes or operations of both the programming models or the structures. Here machine learning, it is a subset of AI, we just understood that it is a part of AI only, and here the algorithms, they learn from the data and they will predict. And moving on to the deep learning, this is a subset of machine learning. So, whatever the ML is doing, the same thing DL will be doing, but the only difference is here we will apply the neural network concept. Neural networks are the human brain mimic part. Okay. So, they automatically learn the features, and from the large amounts of data, they form the useful patterns. Now, while moving on to the other differences, these are ML, machine learning models are well suited only for the labeled task, while the deep learning, it handles the image processing or the natural language processing concepts. It handles the complex task. Now, while moving on to the other comparison between the computational speed or the other ways of working, how it deals with the data, computational time is very less in case of machine learning model, but computational time is very more to train the models of deep learning. Here the model will extract the features here in an object, and this is done manually, but in case of deep learning, automatic extraction of features have been done. Moving on to the other differences, here the data is very small, and in case of deep learning, the handling of data will be very large. Moving on to the other differences, this works for structured data, where deep learning works for unstructured data, means it works for images, audio files, video files, textual information, etc. Now, the algorithms, how we are going to model the machine learning and deep learning, the algorithms are SVM and k nearest neighbor, while in case of deep learning, it uses different networking concepts like, that is neural networking concepts like the convolutional neural networks, recurrent neural networks, etc. Now, here these are applied statistical algorithms have been applied to form the hidden patterns, while in here in case of deep learning artificial neural networks architectures are applied to find the hidden patterns. While coming last comparison, here ML is less complex and easy to interpret the results, while in case of DL it is more complex and the extraction of results is not at all easy. Here this picture gives a good understanding of how the input output is being built using ML and DL. Here the user information input is given, features are extracted manually and then the outputs are being introduced. While moving on to the DL, feature extraction and classification is done automatically. Here gives this mind map how the DL is being applied in various applications. Till now we have just discussed what is the importance of traditional programming language. We have done all automation tasks, mundane tasks of human day to day activities we have automated using the regular programming languages. Then we moved a next level to the machine learning, where in machine learning some models have been built to analyze the data sets, and these data sets by analyzing or automating or building a model, they just introduce or produce some unknown patterns from the data. Then comes the image interpretation, the deep learning. Now, here we will look into different applications of deep learning. We can just see what are the different resources that helps deep learning, different applications of deep learning and different challenges faced by deep learning. What are the different tools and frameworks for deep learning to be built? Now, moving on to the first one, what are the different applications? We already discussed that the deep learning models are built only on objects, image understanding or visualizing the images or getting the patterns from the images. So, while moving on to the applications of it, the main applications are recognizing the images or the speeches or interpreting the natural languages that are spoken by the humans. Moving on to the image recognition, it can be a computer vision or it can be a facial recognition. In case of speech recognition, it can be a voice assistant application or the transcription services. While in case of NLP, we have so many languages in India and these languages are being dealt with the help of chatbots or with the sentimental analysis. So, these are the various applications in real world where these deep learning models have been applied. Now, moving on to the challenges. We are talking a lot about the generation of programming methods. In deep learning, the challenges are, main thing is the quality of data. Data should not be overfitted or the computational resources we have in this world till now. So, these challenges, how they are going to deal and how these challenges can be overcome, we can see in the next coming slides. Now, moving on to the other things, the different resources, where they are available and the different tools. We can see that a lot of libraries are built into Python. Some advanced libraries like TensorFlow, Keras and PyChart, these libraries helps to build the deep learning models. Now, moving on deeper into the applications, we can have a focus or an idea of how deep learning helps in different applications in the real world now. We see the object recognition or the image recognition is one of the most important applications of deep learning models. Here the images, the videos, the objects have been recognized and they are helpful in self-driving cars or medical image analysis. The second application is we can divide the images based on regions or based on contents, and this helps in facial recognitions in attendance system of employee databases, or they can be used by autonomous robots, where robots can analyze or they can just visualize the images. And third one is image captioning. This image captioning is, it generates a description for the images and these are helpful for visually impaired individuals. And fourth application is the video analysis. So, any content in the video can be analyzed. We can analyze it for its action or recognition or any anomaly detection within the video. or we can even track an object how it is moving on in a particular video. So, these are the very popular applications of deep learning. While moving on to the other applications, we can see the text summarization. Here, how the deep learning helps for text summarization is, it can just concise or summarize a lengthy document, and it can give you a crisp of the information or a comprehensive of the document. Moving on to the next application is the machine translation. Here, this helps in for the language barriers, where informal communication has to happen between two different languages or between the humans with different languages. Here, the machine itself translate the languages from one to the other language. Moving on to the next application, the sentiment analysis. Here, an emotional tone of the customer from the social media apps or from social media tools can be analyzed on any particular concept. See here, we will analyze the business event to understand the customer feedback, or we can do an analysis of a hot concept that is going on in social media. We can analyze the user feelings or emotions using this, and this can be even when you move on to the business side application, even in marketing, it helps us to improve the sales of the products or the services. Moving on to the other application of voice assistance, here these are some of the voice control devices are there, like the smart speakers or mobile phones, where they can just take in the user input as a voice and they will respond, or they will given to the spoken commands. Moving on to the other applications, other business applications, we can say speech to text conversion. Here the words have been taken and these words will be written by the system, and this will be very helpful for the hearing impaired people. And while moving on to the e-commerce, here this e-commerce applications, we can recommend to the users the products basing on their browsing history. And in entertainment like TV channels, we can even recommend movies or TV shows or music that are being played by the user basing on their user ratings or their viewing habits, or we can enhance the entertainment experiences. And the last is the news and the content application. Here we can recommend the articles or the news stories or even the videos based on the user interest and the reading patterns. We can give the personalizing information consumption to the users. So, these are the various applications of deep learning. Now, exactly moving into, we till now just discussed about what a deep learning is and what are the different applications that are available in the real world with these deep learning models. Now, we will see exact what the advantages of this. As this deep learning model, it takes up the large amount of information or it acts upon large data sets. The main thing, the advantage we get is the high accuracy, how well it builds the model and how well the data deals with this. And second one is the flexibility of different libraries that are available to process the data. Then the scalability, scalability is how much compatible it is to do a large computing power. Then automatic feature extraction or the automatic feature engineering, where these applications will automatically take the features from the data set. And last one is the continual improvement in the process of learning, where by again taking the data sets or the training data have been taken, this deep learning model helps us to give better accuracy. Moving on to the disadvantages, we already know that deep learning models work with large amount of data and the two with high computation power. So, the disadvantages might be it needs high computational requirements, it needs large amount of data, interoperability between the platforms might be difficult, and sometimes because of overtraining the data might be overfitting, and this is a black box kind of application where everything will be in form of a inside hidden thing. Now, moving on to the actual deep learning model. What we will do here? In traditional programming languages, we know well off with a concept called software engineering. What does the software engineering does? What are the principles of that? If we just look into that, they gives the steps to build the software. So, right from requirements, analysis phase, data implementation or database phase, coding phase, and how we will implement testing and back the maintenance. As we come, as these are the steps with software engineering, here in deep learning models, what are the steps? Because we are not dealing with any database here, instead of that we are dealing with the data sets. Data sets is a collection of rows and columns of information, whereby those information are related to one particular problem. So, how we have to go through? What are the steps for engineering a model? Here comes the model steps. First one is the data collection. In any of the models, we need to first gather the relevant data, that is very crucial, and the data should be of a very good quality. And if the data is of very good quality, quality data here mean that there is no noise in the data and there is no error in the data, and this will impact the performance of the model. Then comes the data cleaning part, where even if we get the data that is not of much quality, here we have to remove some of the errors or inconsistencies or the missing values within the data, and this phase is very important and crucial phase of any deep learning model. Then only we can use the data for the training the model. Then comes the next step called the feature engineering. Here the system, we need to provide the system the intelligence to extract the features automatically. So, this phase actually transforms the raw data into meaningful features, which is very essential or important step. Then comes the fourth one, data normalization. Here we will scale up the data to any common range, which will prevent some bias, some errors, and it will improve the training efficiency. Then comes the last phase, data splitting. Here the given data set is taken into training set, validation test and validation data and testing set, and this phase allows to build the model for evaluation and performance assessment. Then how the previous steps can be put in use such that we get a better optimized model. So, here are the optimization. In order to get an optimized model, what steps we have to take? So, the first phase is initialization, forward propagation, loss calculation, back propagation and optimization. So, in initial phase we need to set up the initial values, like how much from input layer to the output layer. There might be several different hidden layers. So, the role of hidden layers is to provide the neurons in that phase to give that input data from the previous neuron and to increase its initial weightage, such that any bias, if they have been occurred, how we have to remove it from the data. Then comes the forward propagation. Here in this phase, the input data that is fed through the network is being generated over the layers and prediction phase follows. The third one is the loss calculation, which is very important. If we see the difference between the actuals and the predicted, if the output is not up to the mark and it is not quantified, actually the difference is being calculated. Then comes the back propagation phase, where here in this phase the error that is propagated backward to adjust the weights and bias. Here in this phase, if you have taken some initial values to the weight and bias and we have calculated some through the layers, if the efficiency of that model is not correct, then we will propagate back the errors over the network again to recalculate and readjust the weights and bias. Now comes the optimization phase. Here we will apply some algorithms, which we will discuss these algorithms in coming sessions. The algorithms like gradient descendant are used to minimize the loss function. So, moving on, how these phases of deep learning models, we have just now come through the steps, and then how the model is being optimized, how it is done using these components. So, the components are forward propagation, backward propagation, optimization, activation functions and loss functions. So, all these 5 components makes the deep learning model to build. In forward propagation, here we take the input and it is being forwarded from one layer to the network until it passes through all the layers and reaches the output. So, the role of forward propagation is to move on the data over the layers. Moving on to the backward propagation or the back propagation, this is an iterative process. You keep on moving the chain once again until you get the better quality or the accuracy with the data. Moving on to the other components, these are very important in building a deep learning. The optimization phase, the activation function phase and the loss calculation phase. If the loss is calculated and we feel that loss is high, then we again use the back propagation method to use some of the optimization techniques, or we will put some activation functions into the network. See here, some of the optimization techniques or algorithms we have is gradient descendant algorithm, stochastic gradient descendant algorithm, which we will discuss in coming sessions. When you see the activation functions, there are several different activation functions. Some of them are sigmoid, tanh and ReLU, and these are activation functions that helps as a catalyst to convert the input to the output through the neural networks. So, loss functions, we already know that when the accuracy of the output is very less, in fact, we will find out the error and rectify the error. So, till now we just discussed about how the deep learning models are built through a step of processing steps, optimization building models or building the models with better optimization, or what are the different components that helps the deep learning model to build. Now, moving on to the actual how an architecture of deep learning will be. So, what are the different architectures that help for different applications? We have seen several different applications, 12 applications we have just come out with 12 I have discussed just now. So, each one of these applications uses different architectures. In deep learning, one particular architecture is helpful for generating one set of applications. Now, if you see the convolution neural networks, which is the first type of architecture, here it is mainly used for image recognition or the object detection and object classifying. So, if your work is around image recognition, object detection or classification, we will be using the convolution neural networks. Then comes the RNN. Here RNN, recurrent networks. So, these recurrent networks mainly is used for sequencing the models. Mainly it is this type of networks or architectures will be used for language translation and the text generation. So, our application is based on the natural languages, we will use the RNN architecture. Then the LSTM architecture, this is a long short term memory architecture, where here a memory cell will be there, and this special memory cell is mainly used to remember the longer sequence, and it is mainly used for the applications or tasks such as recognizing the handwriting or predicting the stock prices. And the other architectures are the GAN architectures, autoencoders, reinforcement learning, DBNs and transfer learning. So, we will look into these architecture deeper into the coming sections, but now for time being we will just analyze or just put a thought on the concept like GANs are mainly used for image generation or text to image synthesis or video colorization. When you take the autoencoders, they are mainly used for data compression or dimensionality reduction. So, those kinds of applications are very well done with autoencoders. While moving on to the reinforcement learning, this is one type of machine learning architecture, whereby here the agents will learn they will have the learning about the data set to perform the task, and it will always interact with the environment. Moving on to the DBNs, they are primarily used for unsupervised learning feature, and transfer learning, these models are helpful for training one problem to be reused for the other ones. So, these are some of the architectures of deep learning models. While moving to the exact comparison between these models, I have just now discussed that CNNs are very well suited for image and video analysis. Recurrent neural networks are well for some sequential processing applications, such as it might be a text or a audio or a time series data, where some maintenance of past information is being kept. Then comes the GANs, where it is a generative adversarial networks, it is mainly to generate the images. Moving on to the next concept of frameworks, we come across what makes deep learning model to work. Here are some of the libraries, some libraries, very important libraries where we can build the deep learning model are TensorFlow, Theano and CAF. So, this TensorFlow, they have a very good library in Python, and they offer comprehensive learning features where it helps in building the model, training, deployment and have the visualization tools. They have variety of application. We can build any type of application such as NLP, time series or image recognition using this TensorFlow model. And the main advantages of TensorFlow libraries are its robustness, scalability and it supports various hardware platforms. Moving on to the next library framework is the Theano, and it is mainly used for the mathematical expression, mainly to optimize the deep learning model. Here the main advantage of this is its computational speed and efficiency. Moving on to the third type of model or the framework is the CAFE framework, which was developed by Berkeley Vision and Learning Center, and this main usage of this is it handles large data sets and it has high performance with minimal computational resources. That means, it is well suited for large scale image processing tasks. Now, till now we discussed about the deep learning modelings or the steps that build up, advantages, disadvantages and various applications of it, and what are the tools that bind up the deep learning models. Now comes what is the actual challenge of this deep learning into existence. The various challenges are data availability, because we need large amount of data to handle the deep learning model, and we all know that deep learning is very time consuming because we work on large amount of data. So, the computational goes on even for days or months etc. Then the interpreting and overfitting. See here we say that it is a black box. So, it is very difficult to interpret the results, and it is overfitting because again you train the model for accuracy, sometimes it may lead to poor performance on the new data. So, moving on, where ahead deep learning is. So, what is the future of deep learning? We can see deep learning is applied to AI ethics, neuromorphic computing, quantum machine learning and edge computing. So, when we think about AI ethics, how it will be applied, it concerns or it relates to how fairly we can take deep learning into the world. And moving on to the neuromorphic computing, here we have to mimic, we have to mimic the hardware in part of the how the human brain is functioning, the same way hardware has to be mimicked. Now, moving on to the quantum machine learning, here we explore the computers to accelerate and enhance the deep learning algorithms. So, edge computing, here we develop or deploy the deep learning models on edge devices such as for real time processing of data. So, these are the different future directions how deep learning come into picture. Then comes our final concept of neural networks. So, till now we have discussed what a deep learning is, why we are building this model. Now comes, for deep learning to be built, we should first understand what a neural network is. So, we say that deep learning models are built on the human brain structure. Now, we need to understand how our human brain works. So, moving on to the lighter part of the concept, we say that this neural network is, it will first mimic the human brain, at the same time it processes the information, and it is also called as artificial neural networks. Here we take some input, we produce some patterns as an output, in between there are hidden layers where input is being again within the hidden layers input is being processed and we show the output layer. Then we spoke much about various components like loss functions or activation functions or some back propagation algorithms. So, all this is put into the architecture layers, what an input layer does, what is the role of an hidden layer and what is the role of an output layer. We all know that input layer mainly takes the input, and how in our human brain a neuron is an input. So, here also each neuron in the input layer represents a feature of the data. Now, moving on to the hidden layer, these layers are very much helpful to take the input data from the input layer, and it is being processed through mathematical functions across other layers through activation functions and pass on the results to the output layer. So, output layer is the final output of the neural network, and here mainly the output deals with how accurately we build the model. So, moving on to the main building blocks of neural networks, we already discussed the neural networks are composed of certain things called nodes which mimic the human brain. There are certain activation functions to just add up our network or boost up our network such that we minimize the errors. There might be some algorithms, backpropagation algorithms, where these algorithms mainly are used to adjust the values between the predicted and the actual values. And then there are several different architectures. We already seen that CNNs, RNNs, LSTMs, etc. I have gave an intro about all this. So, these are the architectures, they are helpful for certain type of applications. So, whatever the architecture we took is depending upon what is our problem is. So, these composed of the neural network. Now, to conclude this session 1, till now we have just discussed or I have introduced you to the concept of deep learning. So, we think that deep learning is a subset of machine learning, which is a subset of AI, and this deep learning model mainly in real world now it helps us to mimic the human brain. So, how our human brain thinks, we have given the decision making capacity to the system, and system itself will recognize an object or segment the object, or it can get some patterns out of the data using the any type of unstructured data, and the system gives a better decision capacity to any of the real world problems we apply. The next one is its different applications in real world. Till now how it is being used, either you take natural language processing or the object detection or any self driving cars or autonomous robots. In all these applications, chatbots, or to give customer feedback or to analyze how a customer behaves in particular situation. So, all these applications we have discussed. Moving on to the architecture, we will discuss these architectures in deep in coming sessions, but till now we are familiarized with the architecture names like convolutional neural networks, RNN, recurrent neural networks, and LSTMs, etc. How each architecture has been segmented or framed to just address one type of application. Then we have discussed some of the tools or libraries which help the deep learning models to be built very well with Python like TensorFlow, Theno, and Cave. So, each of these frameworks are well suited for certain type of applications. So, we build those applications using these frameworks. And the last one is the introduction to neural network, where we just think that neural network mimic the human brain, just we have the neuron in our brain, the same way these models have been built to based on the understanding of the human brain. So, to conclude, we have just discussed or just got a thought about what a deep learning is and what is neural network. And with this we came to the conclusion of the session. In next session we will deep discuss the neural network concept. Now, moving on to the questions we get from these concepts. We should be familiarized more with what a deep learning is, and we have to know about various applications, how it is used in the real world now. Then we have to know about the different architectures of deep learning or the components which make up the deep learning, what are the different parts that helps to build deep learning models. Then a little bit comparison about or the differentiators between AI, ML and DL. Then we can also think about the merits and demerits of deep learning, how in real world whether it is possible to build any model with the deep learning or the computational powers can be enhanced or increased in near future. So, these type of thinking we can just put in with the merits and demerits of deep learning. Then comes what are the various tools in building the deep learning models. We have to understand the different libraries, how we can use these libraries. Then we need to know a little bit about the neural networks. Now, these are the different references, the actual textbook and some of the references which have been made up to make up this session.